Okay, we're still talking about double angle and half angle formulas. So let me actually show you the kind of problem you're going to be asked to solve. So here it is. If the tangent of theta equals 5/4, and then it says theta is greater than pi and less than 3 pi over 2, then find the exact value of each of the following. And then there's 4 parts. They want you to find sine of 2 theta, cosine of 2 theta, sine of theta over 2, cosine of theta over 2. So really 4 problems all under one problem. So they want you to find the double angles first and then some half angles. So let me write down this information and let's talk about it. So they tell us that the tangent of theta is 5/4. Then they say, now this information they give us here is important because this tells us what quadrant theta is going to be in. So if theta has to be between 0 and 3 pi over 2, hopefully all of you will know which quadrant it is, but just in case, or if you want to be sure, you can let your unit circle. Here's pi, here's 3 pi over 2. So I'll make a note here that this angle theta is in quadrant 3. And that becomes important because whenever I want to start plugging in trig functions, I will need to go check whether in quadrant 3 that trig function should be a positive or negative number. So here's what we're going to do. Let's first look at the first part. They ask us, what's the sine of 2 theta? And if we go to the formula sheet, we have a formula, and the key to this formula is, the formula is in terms of sine theta, cosine theta. So we were given tangent theta. If we can figure out what sine theta and cosine theta is for this angle, then we can plug it in here and we'll have the sine of 2 theta. Now we're going to go back to something we've already done many times in this class. If I'm given a trig function and I'm told it's quadrant 3, but I need to determine the sine and the cosine of that angle, how am I going to do it? Well, what I like to do, now you can use trig identities, but I just like to go ahead and create my right triangle. So based off of this information, so-called TOA, tangent is opposite over adjacent, so I'm going to create a right triangle where the opposite is 5, the adjacent's 4, and then I can determine my hypotenuse from Pythagorean. It's going to be 25, 5 squared, plus 4 squared. Turns out the hypotenuse is square root of 41, and just to make sure I don't forget, I'm going to put up here, when I'm looking at this angle theta, I got to remember it's actually in quadrant 3. So now, here's what I do. I say the sine of 2 theta. I simply go, based upon this triangle I've created, figure out what the sine of theta is and what the cosine of theta is, and you plug them in. Sine of theta, sine is so-called TOA, opposite over hypotenuse. Opposite over hypotenuse. Now, be careful, we're not done. Remember, when we do this kind of thing, you get your numbers, but then you have to decide whether this should be a positive or negative number. The sine in quadrant 3 is negative, so I need to actually, the sine of theta is negative 5 over square root of 41. So 2 times sine of theta times cosine of theta. So I go back to my triangle cosine. So ca, adjacent over hypotenuse. But once again, in quadrant 3, is the cosine going to be a positive or negative number? Well, in quadrant 3, cosine is also negative. So now I've plugged in these values into my formula, and now it's just a matter of doing this calculation. Hopefully you all remember when you multiply fractions, you multiply the tops and the bottoms. So negative 5 times negative 4 is positive 20 times 2. So on the top I have 40. Now square root of 41 times square root of 41, when you multiply two identical square roots, you just end up with what's inside and therefore that's the sine of 2 theta. Secondly, now they said, what's the cosine of 2 theta? Now if you look at your formula sheet, this is the one where you have a choice. Actually, there's 3 possible formulas. I mean, you can use any one of them. We have them all. I don't know why, I'll just do this one down here, the third one. 2 cosine squared minus 1. 2 cosine squared of theta minus 1. So I need to know the cosine of theta, which from my triangle, I've already did this once before. I know the cosine of theta is negative 4 over square root of 41. So 2, here's my cosine of theta squared minus 1. So now once again it just becomes a calculation. If I square this, I have to square both. I square the negative 4 and I also square the square root of 41. Negative 4 times negative 4 is 16. If you square the square root of 41, what happens when you square a square root? You just are left with what's inside. So 2 times 16 over 41, you take the 2 times the 16, so you get 32 over 41 minus 1. Now if I want to combine this into one fraction, I'm going to make 1 into 41 over 41. And you end up with negative 9 over 41. So the cosine of 2 theta is negative 9 over 41. So the third part, now they said find, I believe they first asked for the sine. If I can find that problem. I think they said the sine of the half angle. Now compared to the double angle formulas, the half angle formulas are more complicated and messier and a lot more going on. So first of all, we can simply write down from the formula sheet the formula for the sine of the half angle. And I've got it right here. You've seen it before. 1 minus cosine of theta over 2. Now in the previous problems we did, we explained how this doesn't mean there are going to be two answers, a positive and negative. This means there's going to be one answer, and it's either going to be positive or negative, and before we even start doing any calculations, we need to determine what it should be. So this is why half angles are a little trickier than, the double angles, I just had a formula, and I plugged things in, and I got the answers. But here, before I even start to plug in numbers, I have to figure out whether my answer should be a positive or negative number. And here's what you do. You go back way to the beginning when it gave me this information about theta, I'm going to rewrite this so I can show you what we have to do. Whoops. 3 pi over 2. It's because I'm looking for the sine of theta over 2. If I was looking for the sine of theta, well, I know theta would be in quadrant 3, because theta is between pi and 3 pi over 2. However, I want to know about theta over 2. Which quadrant is theta over 2 in? Because that's going to determine, once I know the quadrant of theta over 2, that's going to determine whether my answer is going to be a positive or negative number. So here's what you do. You take this original, this is called a double-sided inequality. So this defines theta. I want to take this and now come up with what theta over 2 should be. Now what we can do in math with inequalities, you know what I can do? There's 3 parts to this. If I divide the middle by 2, then I have to divide each side by 2. So what I've done, I've converted this original inequality into an inequality for theta over 2, which is what I want to know. I want to know where is theta over 2. So now theta over 2 is going to be between pi over 2. Now here's a complex fraction. It turns out you move the 2 up here, and it becomes 3 pi over 4. So now I've determined the angle theta over 2 is between pi over 2 and 3 pi over 4. You can look at your unit circle, but let's just do it here. Here is pi over 2, and here is 3 pi over 4. So theta over 2 is in here someplace. Which quadrant is that angle in? It's quadrant 2. So I know that theta over 2 is in quadrant 2. In quadrant 2 is the sign a positive or a negative number. Well, in quadrant 2, the sign, which is like y, is positive. So I can right now, I just go sort of mark out the negative, because now I know my answer is going to be a positive number. So now I can start doing my calculation. So 1 minus cosine of theta. Once again, I go back up here to my triangle. Now don't get confused, because now I'm looking at theta. This is the triangle for theta. Theta is in quadrant 3. The confusion part is I just spent time trying to figure out which quadrant theta over 2 is in, and it's in quadrant 2. But now that I'm going to do the calculation involves theta. This is my triangle for theta. Theta is in quadrant 3. So I'm going to have 1 minus cosine of theta. So once again, so ka, adjacent over hypotenuse in quadrant 3. So adjacent over hypotenuse in quadrant 3 is a negative. So 1 minus cosine theta is 1 minus a negative 4 over square root of 41. And this whole thing is over 2, and this whole fraction is actually inside the square root. So now I need to simplify this. The first thing I notice is when you subtract a negative, that's the same thing as adding. So now I have this. Now, like we've had to do before, I'm going to go ahead and take 1 plus 4 over square root of 41 and make it into one fraction. Maybe I'll just take the time, because this can get sort of messy. Because what I have to do to add these together, I have to have a common denominator. So 1 I'm going to convert into square root of 41 over square root of 41. So now, written as one fraction, it's this. So it's actually, this is why I said it gets pretty messy. So it's square root of 41 plus 4 over square root of 41 all over 2. And this whole thing is still under the square root. Now, if I move this up here, I will have square root of 41 plus 4 over 2 times the square root of 41. Now, when I originally did this problem, and here's where math can be a little crazy, because I looked at this, and normally in math, I've got a fraction inside of a square root. They normally don't like you to leave a problem in that form. So I'm looking at the answer, and yeah, what I need to do is I am going to go ahead and get rid of the square root of 41 in the bottom. It's called rationalize the denominator. And the way I do that is I multiply the top and the bottom by square root of 40 with square root of 41. Actually, I even need another page, so I'm running out of room. Let me rewrite this just so you can be clear as what I'm doing. In the world of math, if possible, they don't really like to have square roots in the bottom of a fraction. So I'm sitting here like this, and it's like they probably want me to get rid of this square root down here. And the way you do it is you multiply the top and the bottom by this identical square root. Because when you do that, square root of 41 times square root of 4 on the bottom is 41 times 2. I'm left with 82 here. Now in the top, square root of 41, so I'm going to distribute this square root of 41 in this parentheses. Square root of 41 times square root of 41 is 41. Square root of 41 times 4 is 4 square root of 41. So now I've gotten rid of the square root out of the bottom. Now normally in math, they usually don't like you to leave a fraction under the square root. But actually, as I was working this problem, because I have access to the answer, this actually is okay. So yeah, with online homework, sometimes you never are quite sure what they want. My suggestion is at this point, you enter this, and if it's happy, then you're good, and if it's not, then you can check and see if they want it in a different form. So that right here is the sine of theta over 2, and that was a lot of work. And that's why I say half-angle problems are messy. So now there's one more part, part D. They want the cosine of the half angle. Now, the formula for the cosine of the half angle is plus or minus. It looks like the sine, except the one difference is I add here instead of subtract. But now I have to think, all right, for the cosine, is my answer going to be positive or negative? If I go back here, my half angle is in quadrant 2, What is the cosine of quadrant 2? The cosine of quadrant 2 is actually negative. So from the start, I realize my answer is going to be negative. And now I have to redo what I just did a minute ago, where I have to do this messy algebra. Cosine of theta, I go back here, or I can even just look here what the cosine of theta is. Negative 4 over square root of 41, and all of this over 2. So now I have to do the same thing I just did for the sine, so I'm going to skip a few steps. So if I combine these into one fraction, I'm going to have square root of 41 minus 4 over square root of 41, all that over 2. And if I bring this up here, I'll end up with square root of 41 minus 4 over 2 square root of 41. And now I do need to get rid of that square root out of the denominator. So I multiply top and bottom by square root of 41 over square root of 41. And when you do that, first of all, in the denominator, you end up with square root of 4 and square root of 4, which is 41 times 2. So I get this 82 again. And now if I distribute this, I get 41 minus 4 square root of 41. Sort of interesting. Up here's the answer for the sine. And for the cosine, the differences are, first of all, I got a negative out front. But inside the square root, I got a positive here and a negative here. Some people think, well, can I just take the answer for the sine and just change it by changing this in here? I would say, well, if you want to be safe, you better just work it out. If you want to take a chance and just change this to a negative, then maybe it'll work, but it may not work every time. All right, so this was a problem where we ended up finding both half angles and double angles, and like I said, half angles are not actually too bad. The double angle problems can be pretty messy, and there's some extra work to do. All right.